Page 1 of Applications of Differential Calculus. We're going to start with kinematics, which is basically physics. We're going to talk about distance, displacement, velocity, speed, acceleration, which you've all heard in your physics classes, and maybe you've understood it, but if you haven't up until now, hopefully this will be your chance. Okay, so S of t is the displacement function. Displacement. Its magnitude is the distance from the origin, and its direction indicates the direction from the origin, O. Since S of t has both magnitude and direction, it is a blank, not a scalar, a vector, not a scalar. Remember, a vector has a magnitude, a size, and a direction, or a sign usually. Okay, so let's look at this picture here. There's a number line, and it's got the origin at 0, and then it's got a point P, and the directed distance from the origin to P is S of t. And when I say directed distance, I mean it's a certain distance from O, but it also has a direction from O. In this case, it's kind of to the right, which, you know, in math is usually positive. Okay? So when S of t is positive, P is located to the right of the origin, O. When S of t is 0, P is located on the origin. And when S of t is less than 0 or negative, P is located to the left of the origin. Okay? Average velocity is the ratio of displacement in relation to the time taken. So you could take the difference in the second displacement minus the first displacement divided by the difference in the two times, T2 and T1. Okay? So when you're at T1, you happen to be at displacement ST1. And when you're at T2, you happen to be at displacement ST2. So at the top, you take the difference between the two displacements, and the bottom, you take the difference between the two times, and that will give you average velocity. Instantaneous velocity is at a particular time is the gradient of the tangent to the time versus displacement graph at that point. So like if you were going to graph your displacement and time on a graph like this, t and displacement, then usually it'll be kind of like something that grows like that. And basically the instantaneous velocity would be the tangent at any of these points here. So the instantaneous velocity at that time, at this time here, let's say it's called T3, it's the gradient of that tangent line. Okay? So, let's see. The instantaneous velocity, using the first principles which we learned when we first learned about differentiation, that tells us that we're going to take the second displacement minus the first displacement and divide by the second time minus the first time. So basically this simplifies to S of t plus h minus S of t divided by h, right? Because like the t's cancel out. Okay? So that is the expression for instantaneous velocity, which is basically the gradient of this tangent line here. Average acceleration, on the other hand, is v2 minus v1, so the second velocity minus the first velocity, divided by the difference in time, t2 minus t1, and we can rewrite that as the velocity at time 2 minus the velocity at time 1 divided by t2 minus t1. Okay. Each differentiation with respect to time, we calculate a rate per unit of time. So the units for velocity are like meters per second. We can also write that as meters per second with a -1 power. And the units for acceleration are meters per second squared, or meters s to the -2. Let's see. Let's go to 17A1, problem 1. A particle P moves in a straight line with a displacement function given here, where t is greater than or equal to 0 and t is in seconds. So you can probably predict that the way we're going to find the velocity and acceleration from here, given these equations, is we are going to take derivatives. Okay, so since the velocity is equal to the change in distance over the change in time, basically it is the derivative of displacement. And since the acceleration is equal to the difference in velocities divided by the distance in time, it's all the derivative of velocity. So let's use that principle to figure out the answers to some of these. So here, first it starts easy. It says find the average velocity from time equals 1 to time equals 3. So you can see that time equals 1 is going to be t1, is going to be our t1, and then 3 is going to be our t2. And we're going to use our equation from above, which was that the displacement at t2 minus the displacement at t1 divided by t2 minus t1 is our average velocity. Okay, so what is our, if t2 is 3, then what is our st2? Well, let's see. We're going to put 3 in there, so it'd be 3 squared plus 3 times 3, which is 9, minus 2. So that is our st2. What about our st1? We're going to put 1 in for t squared and t here, so we'll get 1 plus 3, which is 4, minus 2, which is 2. And so that's our numerator. What about our denominator? Our denominator simply has t2, which is 3, and t1, which is 1. So let's simplify that. So we have 9 plus 9, 18 minus 2 is 16, minus 2, which is 14, and we divide by 3 minus 1, which is 2, and that will give us 7 meters per second. Okay, and then we go on to the next one. First it says, and then it says find the average velocity from t1 to t1 plus 1 plus h. And so we're going to do the same thing here, except now we got kind of a weird expression for the numerator, because let's see, we're going to put in s1 plus h minus s of 1 divided by 1 plus h minus 1. And that's going to give us the average velocity that we're looking for, b. And remember, we got this quadratic here, so we're going to put 1 plus h in for that, and we're going to get a pretty messy expression here. And it's going to maybe be reminiscent of some of the work we did in the first differentiation chapter. And then we'll put 1 in, and we're going to get 2. We already found that, right? Remember that s sub 1 or s of 1 is 2. And then in the denominator we'll simply have h because the 1's cancel out. Now let's expand this with FOIL. So now we're going to have 1 plus 2h plus h squared plus 3 plus 3h minus 2. And then we have our minus 2 here also, so that would be minus 2 minus 2. And that's in the numerator, and in the denominator we'll have h. Let's see if we can simplify this. So that there's one h squared term, it's that one. What about h terms? There's 2h and there's 3h, that's 5h. And what about constant terms? There is 1 plus 3, which is 4, minus 2, which is also 4. So 4 minus 4 is 0. So the constant term disappears, and now we basically have h plus 5. Okay? And that is the average velocity from 1 to 1 plus h. Find the value of the limit as h approaches 0 of what you just found, right? We just did this, okay? And comment on the significance. Well, if you take the limit as h approaches 0 of h plus 5, then you get 5, right? And so that means that the instantaneous velocity at time equals 1 second is 5 meters per second. Okay. D. Find the average velocity from time t to t plus h and interpret this limit. So I easily write the new expression here. You can see that it looks exactly like this, except for all the ones became t's, so it's pretty easy to write. Now I'm going to expand it with FOIL just like I did before, or I'm going to substitute in, actually. Remember that when I put t plus h in here, it's going to be t plus h squared, just like I had here, except for instead of 1, I have t. And then plus 3 times t plus h. And then instead of minus 2, it would just be, it would be just minus 2. And now I'm going to subtract out something that is basically this expression here, except I'm just going to substitute in t, and when I do that, when I substitute t in for t, it looks exactly the same, right? So I'm going to have minus a t squared plus a 3t minus 2. And then, and now I'm going to, let's see, let me rewrite that, that's kind of messy. And then I divide by t plus h minus t, which is just h. Okay. Now I'm going to expand this out with FOIL. It's going to be t squared plus 2th plus h squared plus 3t plus 3h minus 2 minus t squared minus 3t plus 2 all over h. Now let's start canceling some things out. So the t squareds cancel out, the 3t's cancel out, and the 2's cancel out. So what are we left with? We're left with 2th plus h squared plus 3h divided by h. And so now the h cancels out with some of these h's, and we're left with 2t plus h plus, is that a 3 that I write there? Awful handwriting here. My handwriting's already bad, and then when I write on this iPad, it's just like terrible, right? Okay. Ugh. Okay, so the answer is 2t plus h plus 3. And then what happens when I take the limit of that as h goes to 0? Limit as h goes to 0 of 2t plus h plus 3. I get 2t plus 3. Okay, and then it says discuss the meaning of that. Now the meaning of that would be the instantaneous, the instantaneous velocity. So this would be the instantaneous velocity at time t. Okay, so it's a useful expression that whenever you want to know what's the instantaneous velocity at time equals 2, then you just put 2 in for t. What's the instantaneous velocity at time equals 10? You just put 10 in for t. It'll give you the instantaneous velocity at any time of the particle which obeys this expression. Okay. And then you can see that since we're using first principles to find the instantaneous velocity, eventually we're going to just say, okay, we don't need to do first principles. We could just take the derivative, and it's much faster. Okay, now we just have a similar problem. It's got a different expression for the velocity. Oh, now it's like instead of giving us the s equation, s of t, it's giving us s of t. Instead of giving s of t, it gives us v of t. So I guess they're going to ask for the acceleration now. Find the average acceleration from t equals 1 to t equals 4. Okay, remember the average acceleration is equal to the second velocity minus the first velocity divided by the second time minus the first time. And the second velocity would just be v of t2 minus, and then the first velocity would be vt1 divided by time 2 minus time 1. Okay. And what we do know is that the first time is 1 and the second time is 4. So what we could do is we could write here, actually this is t1 and this is t2. So we could substitute in and we could put 1 and 4 into this expression here to find out what the numerator is going to be. So let's do that. We're going to do first this term here, v of t2. So we're going to put t2, which happens to be 4, in for 2 square root of 4 plus 3. And then we're going to subtract out vt1. So we're going to put t1 in there, which is 1. It's going to be 2 square root of 1 plus 3. And the denominator would just be t2 minus t1, or 4 minus 1, which is 3. And now we can simplify this. We'll have 2 square root of 4 is 2 times 2, which is 4, plus 3, which is 7. And then 2 times 1 is 2, plus 3 is 5. So 7 minus 5 is 2. And then 3 in the denominator, so 2/3. Okay, so this is the answer for A. 2/3 is the average acceleration between t equals 1 and t equals 4. Now find the average acceleration from t equals 1 to 1 plus h. And so now we're going to use basically first principles again. So for B, what we're going to do is we're going to take 2 square root of t2, which is 1 plus h, plus 3 minus 2, and then this time we're going to just take t1, which is just 1, t1 and t2, right, plus 3. And then we're going to divide all that by 1 plus h minus 1. So in the denominator, we end up with just h. In the numerator, we have kind of a messy thing here. It's 2 square root of 1 plus h, and then plus 3 minus 3, and then minus 2 square root of 1, looks like that, okay? And then we could take the 2 and factor that out. Now we're going to pull a maneuver which I don't expect you to have, that you would know how to proceed in this case, but remember the popular factoring that comes up on the SAT, which is x squared minus 1 is equal to x plus 1 times x minus 1. Remember that one? So we're going to use that trick here. Do you see how this kind of looks like that? It's like a something minus 1, and that's a something minus 1. So if we multiply that by a something plus 1, then we can get rid of the square root, which is kind of what we want to do. So let's do that. Okay. Maybe if you've seen this trick once, then you can pull it off later if you see a similar situation. Now, this is a pretty hard problem for the IB exam. Okay, and then we're going to multiply all that out. So when we do x minus 1 times x plus 1, remember that we get x squared minus 1. So in this case, x squared minus 1 is actually square root of 1 plus h. That's the x part, right? Squared minus 1 on the top. And then on the bottom, we just get kind of a big mess here. We get h times square root of 1 plus h, And then on the top, don't forget we have the 2 there still. Okay, so now let's simplify that. We have 2 times 1 plus h, because square root of 1 plus h, quantity squared is just 1 plus h, right? Minus 1. And then in the bottom we have h times square root of 1 plus h plus 1. And then so what we end up with here is 2h over h times square root of 1 plus h plus 1. And remember the h's cancel out. We end up with 2 on top, and we end up with square root of 1 plus h plus 1. And then if we take the limit as h goes to 0, this would end up being 2 over 2. Right? 2 over the square root of 1 plus 1 is 2, which means that the answer is 1. So the it would be the instantaneous acceleration at t equals 1 is 1 meter per second squared. Okay, so that was the answer to we found the average acceleration. The average acceleration would be the answer for B. It would be this here. Okay, but then in C they say, hey, what if you take the limit as h goes to 0, and then that would give us this answer, which would be the answer to C. Okay, and what about D? Then it says, okay, make an interpretation of this expression here. V of t plus h minus v of t divided by h. What is, as h goes to 0, what is that? It's the instantaneous acceleration. What horrible writing. Instantaneous acceleration. Okay? So that's the answer for D there.